Hello. In this video, we want to review together the device vibration tester or portable handheld vibration measurement device, brand UNI-T. Model UT315A. Now let's take a quick look at its box. Well, it says if it is acceleration, what range it works on, what accuracy, and what frequency. Keep in mind the sensors connected to these, which are visible in their photos, and also when we open the box to review. All of them are acceleration. So actually these do not have velocity and displacement. They come by integral calculation from acceleration, and by taking integral over time, velocity is obtained, and from velocity by integral, displacement is obtained. These ranges that are written, the higher ranges definitely have error, but the lower ranges are more important. Accuracy 5% is also a reasonable accuracy. 10 kHz in every 110 kHz also for acceleration is suitable. For velocity, also 1 kHz standard. Next, we want to review a strange point about the units. Now at the beginning of the video I explained that this is acceleration, velocity, the error percentage I explained. Now I want to say its problem. That it has a strange problem here which may bother you a lot with the device. In acceleration it says I measure up to 199, 200 Hz per meter per second squared. Unfortunately, this meter per second squared is only peak. That means you cannot convert it to, for example, its option does not exist, to convert it to peak or RMS, the first one. Or you want to say I want to get vibration acceleration based on G. Unfortunately, it does not have unit conversion. And also the peak example, it also does not convert. And this itself may cause you trouble. What trouble? You go to a technician or a manual exists or a datasheet which says if, for example, you measure vibration of this bearing, if it was more than 2G, you should know that it needs maintenance and has fault. Usually devices themselves come with this unit conversion, this meter per second squared or G, they do it by software. That means in its settings you set that I want acceleration based on G. Unfortunately, it does not have it, or if someone says, okay, I will convert it, well, it makes it difficult, and one worse problem. In datasheet, it says 2G RMS. Here you are reading peak, there is almost 20–30% difference. And that is a large percentage, and it comes by taking integral gives velocity. Now this velocity that it gives, it itself emphasized that my velocity is only RMS. You cannot also get velocity peak. And its unit is centimeter per second, completely an unusual unit. The standard unit for velocity is millimeter per second or inch per second. And all datasheets, articles, people who work with analyzer vibration or protection work with those two units. This centimeter per second is also very strange, notice this too. That means you always have to convert it, and also velocity peak you will never have. Its displacement is millimeter, and it does not have micrometer. And it does not have meals, because meals and micrometer are used more, and this is peak to peak. Everywhere it should be peak to peak, here also it is peak to peak. And does not need conversion, but the point is usually vibrations have small displacement. For that reason they measure in meals or micrometer, not millimeter. This may cause these fixed units and their RMS and peak to make trouble for you. I said in this review to explain it very clearly, to say why each device can have some advantages and some disadvantages, and we should decide based on that for purchase. This device, in my opinion, although it had separate G sensor and had good performance, had sensitivity test. But in its frequency test, for example, up to 3 kHz it responded well. From 3 to 10 kHz, in my opinion, it did not respond positively, no score at all. And also its units can become troublesome. And you should see if you want to be more sensitive about units, you choose another device or not. if units are okay for you. In my opinion, considering its price, it has good capabilities. Depends on your need and your usage, and next we want to open it together. A box with soft body and foam inside it as protection. This is the device itself. Now we will talk more about it. This is also the charging cable. This is also the magnet. We put it in the picture. This is the probe, which we will talk about. This is also the short probe. Brand UNI-T is a known Chinese brand that we have mostly seen its multimeters. This is its vibration measurement equipment. In the initial review, well, it uses battery. You can also have extra battery, open the screw and put your battery, or use rechargeable battery. No difference, we turn it on, and we also want to get data from it. Well, the sensor remained outside the box, no special brand written. I think it is almost 1 kilogram. 50 grams or 40 grams? Well, we open this screw. This screw is for permanent mount installation. We attach it to the magnet. You can connect this probe to it. And for places that are plastic, wooden, or aluminum where magnet cannot attach, with this probe you press and measure vibration. The longer the probe, at higher frequency it damps more and does not show. For that reason, small probes are also included. We open this cable. The sensor is 4-pin. We turn on the device. Well, we go next to vibration calibration device. We do a test from this device. Here we can, with its buttons, choose acceleration, velocity, displacement. We select acceleration. The range it wants to show is between 10 Hz to 10 kHz. Less or more than those it wants to filter. Of course, this range is adjustable. The calibration form we also put on meter per second squared RMS, but here it is peak, meter per second squared peak. Here in the picture reference, it produces 11.3 meter per second squared peak at frequency 10 Hz. Here we get 10.9. Well, here we can do two tests: frequency test, sensitivity test. In frequency test, we set frequency constant, like here at 100 Hz, and reduce amplitude. One of the challenging places for devices and sensors is at low amplitude. For example, at 0.1 here shows just 0. This issue is very challenging. And of course, my difference here and there is calculated and error percentage is obtained. In my opinion, the data it now shows is very good and acceptable data. We go to value 10. we go higher. More vibration. Becomes 32, you see it follows it. Now the hard challenge is frequency test. We say keep amplitude constant, almost at this low set it at 10. Here fixed at 10 meter per second squared peak. Now we reduce frequency. Another challenge comes. Almost 20 Hz. Let's go 10 Hz. We go at 10 Hz, now we had problem. Differences increased until it reached itself. Let's go high frequency. 500 Hz. Now unfortunately low battery and battery finished. Let me see if it gives me data. Now we go on 2 kHz. Already at 2 kHz the differences increased. Now it reached itself. 5 kHz. Almost 40% error occurred. You see now in its box it was written up to 10 kHz. It was supposed this equipment works. In its box it was announced up to 10 kHz. But at 5 kHz you saw it had 40% error. And I tested at 6 kHz, 7 kHz it becomes more. Maybe at 7 kHz it reaches 100% error. The best working range of this device is almost up to 3 or 4 kHz. I just want to say one negative point that really stood out for me about this device. Its cable. Why? Because its cable at one side connects to sensor. Very good connector. But on the other side with the device it is integrated. Usually they put a BNC port or something here so if cable is damaged, you don't need to throw away the device. But unfortunately here for no reason, they directly connected cable here and if the cable is torn or damaged, it will be a big story. Now some say okay we will change the cable, but its cable is special cable. When it reaches the point that you open it and change cable, your error percentage increases. And reliability of equipment decreases. Problems come one after another. Thanks for watching this video and don't forget to like and subscribe.